Hello, I'm Richard with EV4U Custom Conversions. And in this episode, we're going to talk about wiring. Most specifically, the control wiring, the 12-volt system. Now, this is my favorite part. Any of you who've watched the channel for a while will know that the wiring is my favorite part of the conversion. It can also be a very time-consuming part of the conversion because you have a lot of little things to do. Yesterday afternoon, wired up the AVC2. Now, for those of you who don't know, this is just a little device that works with the J1772 charge port. It allows our vehicle to communicate with the EVSE, or the charge station as people call it. Now, just a simple little device. We'll swing the camera around, let you take a look at it. Okay, now the bulk of our 12-volt control wiring is going to be in one little spot here on the passenger side of the vehicle in the engine compartment. And so it's just very compact. So I was talking about the AVC2 right here. Well, you can see 1, 2, 3, 4, 5, 6, 7. There's 7 wires that go to just this one little device. And 2 of those wires go all the way back to the back of the vehicle where our charge port is. And that's the proximity and pilot signal wires. So my point is that just wiring this one little device takes a fair amount of time. We had already run the lines forward to rear way back when we were waiting for parts. So I didn't have to do that. But the time it takes to cut wires to length, strip them, put on connectors, so forth, just takes a lot of time. The routing, the thinking about where things need to be, and so that they'll be easy to, troubleshoot or whatever. You got to think about, down the road, and also a little bit, for aesthetics. But we don't worry a whole lot about the aesthetics at this point. I mean, we got to put some forethought into it. But things will be loomed and wire tied and dressed up, later on in the conversion. So right now, what we're doing is we're wiring up the 12-volt stuff. So the 12-volt supply is down here in the corner, not on camera. Let me see if we can back up. But it's, again, on the passenger side. There's the 12-volt battery. So here's our 12-volt supply. This is where it all originates, right here. And then that 12 volts comes up here to a bus bar. And off that bus bar, we take all of our 12-volt unswitched circuits, or most of them, the main ones. And so one of those is a line that came from the battery that powers the car. So all the 12 volts for the vehicle itself has not changed. We just changed the wire location from the battery terminal over to our bus bar. Then other things that come off of here are instrumentation is unswitched. We have some things that have fuses that are in line, such as the vacuum pump and the power steering. So those main power lines come off of there. And then everything else will be switched through our power relay, which is right here on the firewall. And that is activated by 12 volts that comes off of the original fuse block for the vehicle. And that fuse location originally turned on the electric fuel pump. So whenever the ignition's turned on, the electric fuel pump would come on. Well, we no longer have electric fuel pump, so we're now pulled off that spot on the stock fuse block, and it comes over here and activates this power relay. This relay then takes power from the bus bar, unswitched 12 volts. It goes through the relay and to our fuse block right here. So all of the rest of our circuits that are part of the conversion, all are separately fused on a separate circuit that basically goes directly from the battery through our relay in here. And that relay is switched by the ignition. That's our only connection to the 12 volts of the stock vehicle system. Everything else is separate, that we add, that we fuse, that we switch. So next, we have a terminal strip on the inner fender here. And all of our stuff that comes from the car, you know, things that are kind of permanently mounted in the vehicle, will all be on one side, and then component stuff usually goes on the other side. This smaller terminal strip right here, we have one spot is for ground, so we have a spot to pull off. Most of your devices require ground, so here's where we pull off a lot of the ground right here. It's got a good ground and then goes to this terminal strip. And then we have 3 locations that are for the throttle. So one side of the terminal strip, 3 spots go to the throttle. The other 3 will be the lines coming from the controller. So if you had to pull out the throttle or you had to pull out a controller or whatever, we can remove things quickly and easily. Everything is very modular on our conversions. Also gives you, you know, an easy way to check things without taking things apart or anything. We got test points. Boom, boom, boom. I'm supposed to have 12 volts here. I'm supposed to, you know, you got it. Then we have another terminal strip right here that's on our contactor board, and it's mostly for the pre-charge circuits and the main contactor controls. So that's terminal strip, all that wiring goes to, so that we can pull up this board, basically disconnect things, and this board could come completely out and all those components with it, quickly and easily. So basically what we do now in doing the 12 volt wiring is I've given you the basics. You know, I've shown you our power supply, which is our auxiliary 12 volt battery, and then we have a spot on this one terminal strip, as well as the bus bar here, that are unswitched 12 volts. So anything that requires, like this, well, stereo is already in the vehicle, but anything that we would add, like instrumentation, that needs to have an unswitched 12 volts, this is the source. Then anything that needs switched 12 volts, anything that's going to come on, such as the controllers and everything else, will go through the fuse block. And it gets its power, once the ignition is turned on, goes through the relay to the fuse block. So that's the basis. Now, everything originates from there out. Okay, we've got our power, and of course we've got our ground. So let's kind of talk about where do we go from the fuse block. The fuse block's difficult to see because it's on a black firewall, so it's kind of black on black. We don't have any fuses in at this point. We leave the fuses out. We test the individual circuits, and then we remove the fuse so that as we test different circuits, we don't energize everything every time we turn on the ignition at this point in the game. So as we go along, we want to record everything. And I'm not talking about video. I'm talking about lots of notes, writing things down, making a schematic. Here's the information on the AVC2 board and the wiring for the J1772. So we keep this just for reference. We give a copy to the customer also. They have a complete manual. It's like buying an RV where the refrigerator, the heater, everything has air conditioning, everything has its own separate manuals. And that's how this is. This is a bunch of different components from different manufacturers that are brought together to complete a unit, an RV, an electric vehicle. And so we provide all of the information that pertains to that conversion, as well as for our own reference if we ever had to troubleshoot by afar, and we've done that. And so that somebody else could look at this manual and know what's going on, make it real clear. So this shows, information and the wiring for the AVC2 and the J1772, but it also lists the color of wire that we used for running the proximity and pilot switch or lines, so that there's a reference. We keep track of all of the terminal strips and what goes to what location on that terminal strip. Where is it coming from? Where is it going to? We keep track of all of the schematics, fuse block, everything. Where things are located, so we have a component diagram of where things are in the conversion. For instance, the DC to DC converters are under the panels behind the seats in this vehicle, as well as the shunt, the pack, fuse, and so forth. Not obvious where those things are. So it's all listed, because once you do something, 5 years down the road, you're going to go, how do I wire that up? Well, where do I stick that? And so it's nice to have. And so we have, not just for the 12 volt, but also for the traction pack system, how those cells are all wired together, numbered. We don't always put a number on them. We have a diagram and they're numbered on the diagram. We just did this to do something different this time. And then here's the schematic that's provided by High Performance Electric Vehicle Systems for the controllers. So it shows you how to properly wire up this thing. One of these, I think these are 35 pin connectors. Not all 35 pins are used, and we don't use all the pins that are used. We don't use all those in any one conversion either. So one of the things that we do, and one of the first pin number 1, is KSI, the key switch interface. That's what turns on the controller. That's 12 volts to the controller. Now, we add something in there that's not shown on their schematic. And there's 3 things that we add in series with that, so that certain conditions have to be met before 12 volts gets to the controller. One is, it goes through an inertia switch. It goes through the relay on the AVC2, which if the vehicle's plugged in, then would disable the vehicle. So the vehicle can't be driven away while it's plugged in. And the other is a low pack protection, so that if the pack gets to a minimum voltage, we shut off the controller, or we don't allow power to the controller. You can also program that into the controller, low voltage setting, that we build redundancies into this. So once it goes through those three things, inertia switch, safety interlock is what we call it, keep the car from being driven while it's plugged in, and then the low voltage, pack low voltage protection, then we would get the 12-volt signal to the controller. And so it's that simple. We did one circuit. Then you can move down the line. And you've got tachometer driver, brake light relay, pre-charge. Well, I'll take the pre-charge for instance. It's pin number 4. And it tells you the color of the wire. So that's an orange wire, 18 gauge. We're going to take that orange wire, and that's the pre-charge relay for the primary controller, which is this one. And we know which one it is on this terminal strip. So we're going to connect that orange wire to this, cut it to length, strip it, put a ring terminal on there, and attach it to this terminal strip. Bang, another one down. And you just walk down the list and do this. It's, like I said, it's time consuming to do a neat job, but it's not difficult. You just walk down and do these in order. And then because this has the kind of the Siamese motor, the AC35x2, and we have 2 controllers, we also have another connector, and it has even fewer wires and has very few connections, but we connect those too. And some of the connections are easy, like you have a plug that connects to the encoder on the motor, one that connects to the 840 display in the dash. Those things are extremely easy to do. It's just a matter of running the wire neatly and all of that. Now, this is something that's bugged me, and we need to take care of it before we go much further. But we don't have a grommet in this hole right here. Now, this one and this one, where the original heater core went through. So we didn't drill holes in the firewall. They're there. And so we're going to use those. We're going to use this one because we have to fit the connectors for the display and so forth are a little bit bulky. We're going to need the room, so they'll go through there. But we need to get a grommet because we don't want to run the wires where they can chafe against something, and especially not going through sheet metal. That would just be a time bomb, and you'd have an issue there. Other couple comments. One would be that we have the negative strap off the battery while we're doing this. We only reconnect it once we're sure we've done everything right. We want to test something. But while we're working here, nothing is energized. It's really very simple. It's the big picture understanding that is really key, and that's what's so nice about our workshops is we give you the big picture. I mean, we talk about things down to the component level, but it's developing this big picture view and understanding during the workshop that, once in a while you can actually see it on somebody's face when they have that aha moment, when they, man, I get it now. And, they leave going, you're right, this is very simple. What we remove from a conversion is 1,000 times more complicated than what we put in. And if you're a car guy, for instance, and you've worked on automobiles and you you understand engines, well, you've got a lot more aptitude than you need to do this. People go, well, I don't understand electricity. This is very basic. It's a series DC circuit, and there's a bunch of series DC circuits. They're all parallel with the battery, for instance. The traction setup, again, it's a series DC circuit. The only part that's AC is from the inverter to the motor, and they're labeled U, V, and W. So you connect U to U, V to V, W to W. It's not difficult. You hook the power, they're marked, positive and negative. Negative goes through your fuse, goes to negative most part of the traction pack. The positive goes to your contactors, goes through your main disconnect switch, and then goes to your most positive point in the pack. It's just scale, I think, that scares people. It's a series circuit. Power comes from a battery pack, goes through our main disconnect, comes through the controllers, or the contactors, I mean. The contactors are controlled by the controllers. So once the 12 volt signal gets to this, it says, hey, everything's good. It's going to turn on your contactor, which then provides your traction pack voltage to the controllers. And now they're on. Boom. Straight to the motor. The circuit then goes back through the negative side here. You know, we came from our battery pack to the controller, through the controller, through a fuse, through a shunt, to the negative most point on the battery pack. Bang. So simple. And so, I think that's pretty much all we're going to talk about on the 12 volt wiring. It's, like I said, it's just one step at a time. Same way when we do the traction pack. We start at one point and walk through. We usually start at the most positive, and we'll call that cell number 1. So here's positive, and we're going to put an interconnect between this negative and this one's positive. Another one between this one's negative and this one's positive. And you just walk through the pack. Positive, negative, positive, negative, positive, negative. As long as you keep that, double check, you can go through, check with a voltmeter and say, well, I've got this many cells, they're all 2.75 volts, I should have this much right here. Yep, means I must have interconnected everything correctly to that point. Very simple. It's just, you have to be methodical about doing it. And I guess that's why I like it. I like order. And this is just, you know, you can read a cookbook, you could do this. I mean, it's just 1, 2, 3, 4, just walk through the steps, one step at a time. So anyway, if you have any questions or comments, please don't leave them on the YouTube channel, as we don't always look at those, and sometimes the people that do don't know the answer to the question. So the best thing to do is email us. The email address is info@ev4unow.com, and we're happy to answer any questions. So anyway, it's coming along. We'll cut back in a little later, give you kind of an update and a view of things as we progress, but we're getting close. Right now, working on the instrumentation. We have connections to the instrumentation. We always run a 12 volt gauge. The 12 volt gauge allows us to monitor the battery and 12 volt system, as well as the DC to DC converters. We know if one of those wasn't working because it would show up on our gauge because our 12-volt battery wouldn't be being charged. So we also have an indicator light whenever the ignition's on, as a reminder to let you know that, hey, the system's on. So we have a little green light that comes on. All that type of thing is under the dash, and all that's being wired now. We use a JLD 404 for monitoring pack voltage, amps, amp hours, as well as switching. It's got 2 built-in relays, and we use those relays for control circuits. So that's what I'm doing right now. I'm wiring all that up and getting that ready to go. So everything's done under the dash, and we can move on to the stuff that's a little more at, you know, working level instead of laying underneath the dash. Anyway, appreciate you watching. Hope to see you again next time.